Is the number of seconds required to travel d1 feet at r1 feet per second greater than the number of seconds required to travel d2 feet at r2 feet per second? So, statement number 1 tells us that d1 is 30 greater than d2. So d1 equals d2 plus 30. So here we know that distance 1 is greater than distance 2, but here we're given zero information about the rates. One of them could be 10 times faster than the other. We have no idea. So because we have no information about the rates and only information about the distance, we can't conclude anything about the time. So this statement by itself is insufficient. Statement number 2. Now, of course, we have to be very careful here. Ignore statement number 1 and consider statement number 2 on its own. Statement number 2 on its own tells us that R1 is 30 greater than R2. So R1 equals R2 plus 30. So now we know that object number 1 is going faster than object number 2. We definitely have a relationship about the speeds now, but now we have zero information about the distance. And because we have no idea about the distance, we have no way to draw any conclusions about the time. So this statement by itself is also insufficient. The crux of this problem is what happens when we combine the statements. When we combine the statements, we know that distance 1 is 30 greater than distance 2. We know that rate 1 is 30 greater than rate 2. So I'm going to suggest a couple scenarios and see if we can come up with numbers that are consistent with this that will make the answer go either way. So first of all, I'm going to pick something huge for D2. D2 equals 1,000. And then D1 equals 30 greater than that, 1,030. Now I'm going to make R2 something really small, 1. And then R1 would be 30 greater than that, 31. Well, clearly, if you're going 1,000 feet at 1 foot per second, that would take a time of 1,000 seconds. That would take a very long time. That's about a third of an hour, 1,000 seconds. Whereas if we're going 1,030 feet at 31, well, approximate. We know that 900 divided by 30 is 30. So 1,000 divided by 31, a little more than 30. So between 30 and 40 seconds. Clearly, this is going to be much faster than 1,000 seconds. So clearly, this is a scenario consistent with the numbers where object number 1 is faster. So now let's change things around a bit. Now I'm going to make D2 a very short distance, 1 foot. And then D1 would have to be 30 greater than this, so that would be 31 feet. Now R2, I'm going to make this at, say, 5 feet per second. Then R1 is going to be 30 greater than that. That's going to be 35 feet per second. And then when I figure out the times, well, this will take 1/5 of a second. This will take 31 over 35 of a second. That's something much closer to 1. And so it turns out that 1/5 of a second, of course, that would equal 7 over 35 as a fraction. 31 over 35 is much bigger than 7 over 35. So here, the object in number 1 takes a much longer time, and the object in number 2 is faster. And so because we can construct scenarios consistent with the numbers that make either the first object faster or the second object faster, it means that these conditions combined are still insufficient to answer the question, and so the answer is E.